we want to, no. All right. Yeah, what we started talking about last time, we wanted to look at extending, we're designing, talking about sequential logic, and we're designing counter circuits and so forth. And we said that was a segue to what we call a finite state machine, and how we're going to use it to design certain circuits. All right, so on the screen now we have a mixing tank. We have two inlets, one for probably water, the next one for syrup, or whatever the two ingredients are. Is going to mix them together. The level switches that are there, the lower level switch, material A, material B. Now, for the purpose of this class, we're going to simplify the process a little bit. We're going to have one inlet valve, one level switch, one outlet valve. All right, so we're going to have one inlet valve, one level switch, one outlet valve, and the stir and start and stop. So system like this, and we want, the reason why we're leaving out all of the level switches and all of those things is that the more inputs we have, more complicated will be the circuit. And we're trying to teach something, so we don't need to bring it the level of complexity at all. So let me just describe what it is that we do when we're going to do the description here. I better use Microsoft Whiteboard instead. Give me a second. Let's bring up. Waiting for it to load up. All right, so yeah, what? Let me start. I'll go back here. All right, so we're saying that we're getting rid of one of the inlet valves, and we're getting rid of two of the level switches. So the process just has one inlet valve, one motor, one level switch. So it's going to press start, it's going to fill up, and the motor going to turn on, and it's going to be for 10 seconds. I'm saying for 10 seconds. And then it's going to let it out, outlet valve. So that's the process that we're going to be working. It's going to fill in, going to fill up to the level switch B, motor then going to turn on, and then when turn on, then going to run for 10 seconds, and then it's going to, outlet valve is going to open to let it out. Save this thing. Sure, can't bother wait and sometime Microsoft decides them now about a load, so can't bother use the whiteboard. So the whiteboard needs some lights. All right, so this is the process that we have. Oh, okay. Sorry. Give me a second here. Having some issues. All right. Okay. Try sort out this. You seen the whiteboard?
Yes, sir.
All right. We just have to work with this because the Microsoft whiteboard is not coming. So the bad drawing have to go work. All right. So let me just describe the process. So the start switch is push. The inlet opens. Until the liquid triggers the level switch. All right, so this is the description. So 10 seconds. That we can refer to. All right, so press the start switch. The inlet opens, allows fluid to enter. When it reaches a level switch. The level switch triggers the motor turn on for 10 seconds. It triggers the outlet, and the outlet opens to let it out. So this is a sequential process. And so if it's a sequential process, meaning that one thing happens, then the next, then the next, then the next, then we can use the finite state machine to we can use a finite state machine and the digital logic to control the process. So let us begin by looking at first thing that we have to list. We have to list what are our inputs. We're going to be doing the same thing when we start talking about programmable logic controllers, which we do the same controller process by writing a simple program. Fine. All right. So what are my inputs? My inputs are any switches or sensors that we have in the system. So what would my inputs be in this particular process?
Sorry, I have a level switch. One of them.
Level switch.
Start switch.
Is
Start switch.
All right. I prefer to put stop, start. I'll put the stop first, and the start second, and the level switch third. I am also going to put, although it is an output, but in this particular case, the stirrer is also an input.
Yeah.
All right, because the stirrer triggers something else in the system. All right. So we have 4 inputs, and my outputs are the things that are triggered. So it will be my inlet valve, my stirrer, and your outlet. And then the important thing that we also need to list are the states that the system is in. Now, some people just list the states by taking the 3 actuators. So is the inlet on is once everything off. So one state is everything off. That's the system. Or the inlet on is one state that the system can be in. The fluid is running out of the inlet valve. The stirrer on is another state. And the outlet on is another state. So we can just look at the things that are activated in the system, and then we can say the state of the system based on what is on and off. And this part here, so what I'm saying now is that we configure the system so that it's only the inlet alone can be on, the stirrer alone can be on, and the outlet alone can be on. We're not going to have a state where the stirrer and the outlet operating together. If you're understanding what I'm saying. You understand what we say when we say that is
Yes, sir.
them exclusive? Either one on or the next on or the next on, but we're not going to have all of them on at the same time. All right. So now, after we list everything off, since it's three different things that we have here, I'm going to do it this way. Now, well, all right, we'll make my life easier. I was going to say, well, let me do it the easier way. So everything off, I'm going to give it a number, 0, 0, 1. Inlet on, I'm going to give it 0, 0, 1. These numbers are arbitrary, by the way. The stirrer on, I'm going to call it 0, 1, 0. And the outlet on, I'm going to call it 1, 0, 0. Like I said, these numbers are arbitrary. And the only reason I'm just listing it easier, by saying that one is the first one is the inlet, the second one is the stirrer, and the third one is the outlet. All right.
So don't you have 4 inputs? Shouldn't it be 4 numbers?
So now the inputs, I'm going to also give some numbers. And I'll give the number for since we have the states and you have 4 different states, some persons just give each of them a binary number, so it's only 2 binary numbers. But for the ease of design, I'm giving 3 numbers. So one is for the inlet, one is for the outlet, and one is for the stirrer. For the inputs over here now, I'm going to give a binary value for each of them. Now, when I give a binary value for each of these things, what you're going to realize is that doing that, giving a binary value for each of those things, we're going to have additional circuit that we're going to need. But what I'm going to do, again, this is for the ease of making the circuit a little bit simpler. I'm going to, it's 4 different things, so we can use a binary number 0, 0 to indicate stop, 0, 1 to indicate start, 1, 0 to indicate the level switch, and 1, 1 to indicate the stirrer. Now, we could have done the same thing with the states, but for the ease of discussion here, we're going to limit the discussion to limit the giving of each state number of unique binary. So we have 4 inputs. So we can give each of them a unique binary value. But that is going to lead to more circuit design that we have to do, because we're going to have to design a multiplexer. We could have just said start is 4 different inputs. So one of the things that we could have done is a start is 0, 0, stop is 0, 0, 0, 0, start is 0, 0, 0, 1, level switch is 0, 0, 1, 0, and stir is 0, 1, 0, 0. We could do like we will do with the states, but I am making my life a little bit easier for the circuit that we're going to draw because we're in class. But you could have easily, what I'm trying to say. Oh, I could have done this. What I'm trying to say is that I could have done this. Stop is 0, 0, 0, 0. It's 4 different inputs, and one is 0, 0, 0, 1. And the other one is 0, 0, 1, 0. And the other one is 0, 1, 0, 0, or something like that. I could have done that. but that is going to make the circuit a whole lot bigger that we have to simplify. So I'm not going to do that at present. But you can do that when you're doing your design. Four inputs, and each of them have a binary value. All right. So the most important thing that I wanted to get from this is the states that you can just look at the three things that you're actuating, and from the three things that you're actuating, you can write down the different states that the system is in, and assign each of them a binary value. Now, usually, but not necessarily, we usually give binary values to the inputs, and if it can correspond with the states, then fine. So that's what we are going to do. So we're going to give the input the same binary value as the output state. We don't have to do it, but it usually makes our life easier, as you will see. Okay. So we have these four states that the system can be in. And so the next thing that we are going to do is draw a map. So let me use my phone and take a picture so that I can be reminded of. So we'll go over to the next page. Need to remember some of these things. So I wanted to use a Microsoft whiteboard, but so that whenever I have to go to our next page. Sure. Delete. Seen everything. Take over back the picture as all right. So we are here. We have a description of the system, verbal description of the system. And then now with this verbal description of the system, we talk about our inputs, our output, and our states. And then I'm giving each a state a specific binary value based on the actuators that we have in the system, meaning the things that we're to turn on and off in the system. We're also going to need to list the inputs, and then we're going to list the output. Okay, so we're going to draw a state diagram. So the state diagram now. We had three circles not coming out so wonderful. Got it. So I have my four states, and I'm going to number each of the four states. So my four states was everything off, so I'm going to put 0, 0, 0 in that state. And then star on is 0, 1, 0. Outlet on is
And then we go and count. This one is exact.
0, 0, 1, 0, 1, 0. And what was the last one here? 1, 0, 0. So these are my states, everything off. Inlet on, stir on, and outlet on. And the output is usually put a little line for the output. So I'm gonna put it in a different color. So usually put a little line and say what your output is. But my output is the same as my state. So and you see when we join the circuit, how handy that comes in. All right, so these are my 4 states, and these are my 4 outputs that I would want in the system. Now, the next thing now is to look at the transitions. So if I am in the off state, now remember now we have 0, 0 as stop. Let me check.
Yes, sir. 0, 0 stop.
All right. What was happening? 0, 0 is stop.
Yes,
Just write it down. Okay. 0, 1 is start.
yes sir.
1, 0.
Yes, 1, 0 is a level switch.
1, 1.
The stereo.
All right. So we're going to examine each input to a given state and say what the transition. So the diagram is called a state. I said state diagram, but you can also call it more technically correct if it's a state transition diagram. So for example, I am at everything off. That is my first state. And I press my stop switch. What is that going to do?
So it won't change anything.
So it won't change anything. So what I do is put an arrow going back onto the stop switch and put this 0, 0. It won't change anything, so it's going to stay back and it's going to loop back onto itself. So what happens if I press the start switch?
To 0, 0, 1.
So it's going to go to the next state.
Yes, sir.
So 0, 1 is going to carry to the next state. Everything off and the level switch trigger. So now, so consider that now. Everything is off and something happened on the level switch trigger. What should happen?
Stop.
So it should stay in the same state. All right, so I'm going to do this initially, and then we're going to rub it out afterwards and explain why we're going to rub it out. So if the level switch is triggered, it would be 1, 0. What happens if the stirrer is triggered in the stop state?
Remain in our same state.
Going to remain in the same state. Right? So that is the first step in our diagram. Now I'm going to rub out the 1, 0 and the 1, 1 because those are what you call, you can also use the fact that we don't care. Or the X can also mean can't happen. The don't care state or can't happen state. And you will see why in a moment that I will leave these two off. So I'm going to rub them out because they can, I'm going to say that it can happen. Now, when you are doing your design for your circuit, you may want to say, it can happen, so I'm going to make sure that it goes to a state. Some people, when they design the circuit, that's what they do. They make everything that can happen or don't care, make it loop back at itself, so that if anything happens in the system go back to the state that they predetermined. But I'm going to say these two can happen, so I am going to ignore them. All right, so what if I am in the state where what is this now? 001. Refer to my phone. The inlet is on.
Yes, sir.
Inlet is on. I will press 00, the stop button. What should happen?
Go back.
You go back here. Go back to this. So if I press 00. So what if the inlet is running and I press the start button? What should happen?
So it continue running, so it would stay at that state.
So we say that if you press the start button, it should stay in the state. What happens if the inlet is on and the level switch is triggered?
Stop.
All right, remember the diagram now, if we go back to the diagram. The inlet on and the inlet on it run and it reach up to the level switch. What happened when it reached the level switch?
It's all gonna stop, sir.
It's gonna stop and the stirrer going to start.
Right.
All right. So it's going to go to the next state. Inlet is running and the stirrer turn on. That's a can't happen state, so I'm leaving it out of the diagram. All right, so now stirrer is on. Stirrer is on and you press the stop switch.
Stop. Go back.
Stirrer is on and you press the start switch.
Do back to 001. Oh,
I'll loop back to 010. I said, stirrer is on and press the start switch, then loop back onto itself. Continue doing what it's doing.
Yes, sir.
Stirrer is on the level switch. So that's one of the can't happen states, so we're leaving that alone. And the stirrer is on, and then we are at the end of stirring. So this is where the input of the stirrer come, where I have the stirrer as an input. So we're at the end of stirring. What is going to happen at the end of stirring?
move on to outlet.
Move on. So we're going to have to discuss how we know when the stirrer finishes stirring. All right.
You say it's sequential, right? So the clock will take care of that.
Yeah. No, but we have to make sure that the stirrer is going to be on for 10 seconds. So we have to go discuss what we do. We have to put the output of the stirrer to a monostable. All right. So now the outlet is open. Now we press the off switch. Press 00, the stop switch. What should happen?
Go back to 00.
All right, go back to 0, 0. Stir the outlet running out and we press the start switch.
Remains.
And the other two are can't tap, so we're going to leave them on. So this is the diagram that we have, state diagram. So now, the next step in this, so we'll take the picture again, so that we can draw the big. The next step is to draw up the same table that we did draw up last week, or this week. So, meaning now, let me take the picture, we'll take the picture. Right, can I see this picture? No, I can't. Sorry. Okay, we're moving on to the next page. All right, so the next page now. Now, remember, so we have 2 inputs and 3 states. So our vegetable, so we must put a ruler. So here. See how well this works. So now, so I'm trying ignore the line them. So these are, I'm going to call my inputs A and B. And my present state is going to be C, D, and E. My next states are going to be C star, D star, and E star. And then for each.
Sir, many step a while ago. Which table is you drawing?
Okay. Now, so from the state diagram now, I'm going to draw a diagram now. So 0, that's what we're going to put. So C, D, and E are my inputs. Sorry, my states. And then this would be my next state. And these 2 would be my input. Remember last Wednesday when we're talking about the transition going from 0 to 1, 1 to 2, 2 to 3. And if the I equal 1, then we move from 1 to the next, to the next, to the next. You remember that scenario where we said I, and then we had A, and then we had B. And then we say if I equals 0 and you are at if you're at 0, then the next state is that you go to is 1 and so forth. And if I equals 0 and you're at 1, the next state you go to was 2. When we're talking about the counter, you remember that?
Yes, sir.
That is the same table we're drawing now. So now I have two inputs, A and B, and when A and B are both 0, and I'm at state 0, what is the next state that I want? So that is what what this is trying to capture. You understand what we said? You getting the idea?
Yes, sir.
All right, so use a different. I'm going to bring up Excel file and you do this next part as an Excel file. So I put everything in Excel file. So the first two A and B will be my inputs. The next three will be my present state. And the next three will be my next state. So now, so this is I1, we call it I1, I2, A, B, C, and my next state would be A star, so this is JA, JA, JB, KB, JC, KC. I'm just gonna put one little bracket and say output. So it's 32 different configurations we can have. So if it's 32 different configurations, we're going to have 8 zeros. One, two, three. 1, 2, 3, 4, 5, 6, 7, 8. And then 0, 1. I almost feel like not doing this because this kind of indicates and the computing and the typing not working out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we're at the most tedious part. So now, so we have and I'm going to do the whole entire table. You understand? We're going to just do a couple of them. So for example now, with our table, if our input is 0, 0, and we are in state 0, what is the next state going to be? Well, 0, 0 is our go back to the picture.
It's a stop state, sir.
The stop state. So everything, once this is the stop state, then everything 0, 0, and we are in 0, 0, we're going to stay in 0, 0. So if we're in 0, 1, then we're going to go back to 0, 0. If we are in 0, 1, 0, we'll go back to 0, 0. If we're no, so let's just go no, we put 0, there's a state with 0, 1, 1. No, that would indicate that the two pieces of equipment are on the what would that be? The stirrer and the outlet is on at the same time. So what do we put in for the next state in that particular case? What would we put over here?
So repeat that, sir.
All right, we're hypothetically now 0, 1, 1. A being 0, B being 1, C being 1. Hypothetically, is saying that we're at a state where the stirrer and the outlet are on at the same time. What would we put for the next state?
Let's stop everything, sir.
No, we're not going to stop everything. we are going to say that that is one of our don't care states. That we don't, that's this state don't occur in our in the diagram that we have. Let me see if I that we're dealing with some abstraction. We don't have a 0, 1, 1 state in our diagram. So that is one of our don't care states. All right. So if it doesn't, so what I'm trying to say now, if in our state diagram that we draw, a particular state does not appear in it, what we do is ignore it in the when we drawing up the table. So here we have one of the situations where we're going to put X, don't care. Because when we're minimizing, this is going to make our life easier. So that is one of the don't care state. So the next state is 1, 0, 0. And that goes back to off again from the diagram.
That will be on the
Cover all states, 0, 1, 0. Wait, we leave out 1 enough. 0, 0. Oh, this should be a 1. So all the other states that we can have, all of them now will have two things on 1, 0, 1. So that's another don't care. 1, 1, 0 is another don't care condition. So all the conditions that we have where we have two things on. I don't care conditions. So we're going to repeat this here now. We'll just make all right. So this condition at the last point where we have is going to be the same here. Whenever we have two, we're going to have the same don't care condition. Because our thing is saying that we can have two things on at the same time. You following what I'm talking about? Or
Yes, sir.
all right. So what I'm trying to get at is that if your inputs, let me just fix this because it's confusing. Okay. So now we are at 0, input is 0, 1, and we're at 0, 0, 0. What did we say happened in the next state now? 0, 1, and our, so we're at 0, 1, and our is 0, 0, 0. Let me put it in a different color. Yeah, this part of the table now, we're at 0, 1, first point, and our input is what it is. Start, 0, 1 is start, and everything is off. So what is the next state that we got to there?
0, 0, 1.
0, 0, 1. And we're at 0, 0, 1, and we press start. What we said that we would do is stay at 0, 0, 1. That's all.
Yes, sir.
And we're at 0, 1, and we at all of them would stay. So whatever state we are in would stay in that state. 0, 1 start, and we're here, would stay in that state. All right, so the next set. All right. One, we're everything off and 1, 0. What did we have in our diagram? Everything off, 1, 0. Let me go back to the diagram.
Sir,
Everything off, 1, 0 did not appear,
sir.
right? This is 1, 0 here. And everything off, 1, 0 did not appear. When we're at the next state, 0, 0, 1, we go to 0, 1, 0. And when we're at 1, 0, 0, it did not appear. So we would have a don't care condition here. When we're at 0, 0, 1, there's a transition. But for it, it's only one space that 1, 0. 0, 0, 1 to 0, 1, 0. That's the only spot that we have. 1, 0, playing a role. Everything else, we don't care. So I color this differently. All right, so we're saying 1, 0 in 0, 0, we don't care. 1, 0, we're at 0, 0, 1. That is the only one that we got to 0, 1, 0. All right. We're at 0, 1, 0. We don't care. And that one we don't care. Finally, yeah, so the table kind of tedious to fill out, yeah? Especially like was 5. All right, so what about now? Last one. 1, 1. The only place, go back to the one, one. The only place where 1, 1 occurs here. Going from 0, 1, 0 to 1, 0, 0. Everywhere else, there's nowhere else that 1, 1 occurs in the table. So this transition only affects 0, 1, 0 and it carries it to 1, 0, 0. Everything else we don't care. So 0, 1, 0 to 1, 0, 0. Zero, 1, 0. And so what we say, 0, 1, 0. 1, 1 is going to carry it to 1, 0, 0. No. Nope. All right. So now for the hard part of the work. The J's and the K's and the, so remember the transition table. What from A is 0 to A star is 0. I'm pointing at the screen, but so from here to here, what is the J and A that will cause it to? Anybody remember the excitation table? Let's write it back down. Okay, write it down here. Forgot. So if we're at Qn and then the next state Qn plus 1, what value of J and K? So it's 0, 0, 0, 1, 1, 0, 1, 1. What is it for J and K? How that excitation table work again?
Don't
K
care.
don't care. K don't care.
One
One
don't
don't
care.
care.
Don't care. 0.
Don't care what?
Don't care 1.
And then don't care 0.
Yes, sir.
All right. So first of all, let me just fill in most of the table. Oh. Anywhere we have don't care, then we can just fill in and go straight across. So I'm just fill in these from now. All right. So from A is 0 to A star is 0, we have 0, don't care. And it's the same thing going straight across. So and our output is 0, 0, 0. All right.
Yeah,
So
count it account, sir.
huh?
It's counting. You have 0, 1, 2.
Right. Oh, all right. So now A to A star, that says don't care 0. This is also a 0, don't care. And here we have a 1 transition into a 0. This is a don't care 1. All right. So we fill it inside here. So A is 1, this is 0. The other two are both zeros. So that is going to be 0, don't care, and 0, don't care. 0, don't care. 0, don't care. Like I said, this is the tedious part. A is 0. Of course, you can write the Excel file to fill in all of these things. You just run down the table and fill in and the other section. But as it is right now, we're doing it by hand. All right, so 0 and 0, 0, don't care. Next one is 0 and 0, 0, don't care. That's a 0, don't care. And then C is 1 going to 0. 1 going to 0 is don't care. 1. Now, as you are seeing, the table as it fills up, it says a whole heap of don't care. So the simplification is going to be, is a whole heap of simplification going to go on when we are through. All right. So the next B in this column here, B is 1, and B star is B is 1, B star is 0. 1 to 0 is don't care 1. And then now C is 0 and C star is 0. So that is going to be 0, don't care. All right, so for the next column here now, A is 0, A star is 0, that's a 0, don't care. B is 0, next is 0, so that's a 0, don't care. And C 0, C star is 0. C is 0, C star is 1, that's a 1, don't care.
Don't care.
All right, so for the next one, A is 0, That's 0, don't care. Then it's B is 0. B star is 0. So that's 0, don't care. And C is a 1. C star is a 1. Okay, that mess up our table. Don't care 0. Meaning to say, as you can see, like KB it look like it's just going to be a 1. But let us see. All right. So now, we're just going through I'm going through the process because you're going to tell me, say, why is line, you know? Yeah. Oh, so, all right. So I was doing everything to make sure so we don't have no confusion. All right. So where are we? So B is 1 and the next state is a 1. So B is a 1, the next state is a 1. So that would be don't care 0. And then C is and the next state is 0. So that is going to be 0, don't care. All right. And I'm going to finish. Although we almost finished. All right, so let me finish. Okay, the next one is going to be 1, and next state is 1. So that is going to be don't care 0. B is a 0. B star is a 0. That's going to be 0, don't care. Next state is going to be C 0, 0. That's 0, don't care. And the last two, zero to 0, 0, don't care. Zero, yeah, so this is B, 0, B star is 1. That's a 1, don't care. And the last one is C is a 1. C star is a 0. So don't care now 1. The very last one. Very last one now. 0, 1. 0 to 1 is 1, don't care. The next one is 1, 0. So don't care 1. And the final one is 0 to 0. 0 don't care. Okay. All right, so let's discuss where we are so far. So where we are so far is that we have our transition table. And then now this is what we're going to simplify to draw our circuit. So the J and the A, we would have to simplify that to draw our circuit. So then we'll go over to electronic workbench, simplify to draw our circuit. So we'll see if there's anything that, well, we don't have to do anything. Oh yes, there's a 0 here. All right, KA. KA is 1 straight off the bat. JA, we have to simplify JB, we have to simplify KB. Yep. JC, KC, we have to simplify. All right. So the next step in the process now would be, does I check? I'm talking to myself.
No, sir, there.
Okay. So the next step in the process is to bring up electronic workbench and do the simplification. All right, so I'm bringing up electronic workbench here.
Sir, if you have a 0 in KA, would it be classified as 1?
There's a 0 in KA.
Yeah, yes, sir.
Oh, well then no. That was, I thought there was no zeros, pure X and 1 inside. But once there's a 0. Oh yeah, see the 0 here. So that is wrong then. So we have to simplify everything. All right, so now 1, 2, 3, 4, 5. So now we'd have to go and simplify. So in the case of, let's pick one of them and just simplify for the purposes of and the things are not transferable are not that I know of. Let's see. That would be Joy. Yeah, not transferable. All right, so we would have to go through and type in the thing in Workbench. Also, so that is, I'm not going to do that in the class. I'm going to do that for next class. Just going to discuss now the circuit. I'm going to do the simplification, and if you have Workbench or Multisim, I would ask you to do the simplification and see what the circuit is that you're going to look at. Uh-huh.
You draw a circuit already?
No, sir.
You say no about a draw?
Not today. Because we have got to type in all of these X and 1.
Oh,
Unless
yeah.
somebody, all right. You see what you see now?
I'm seeing the Excel sheet.
All right, so quick. JA, run down the Excel sheet and tell me what I must type in. And so I can tell you what the simplification is. I just put it in Workbench.
0. Ready?
Yeah.
0.
Mm-hmm.
0.
Mm-hmm.
Don't care. Don't care. Don't care. Don't care.
Don't care. Wait. How much don't care? Count how much don't care. We must 1, 2.
1, 2, 3, 4, 5, 6 don't cares. Then 1, 2, 3 zeros. Then 1, 2, 3, 4, 5, 6 don't cares. Then
Excuse me.
1, 0.
Mm-hmm.
I think I see 5 don't cares before the 3 zeros that you mentioned.
1, 2, 3,
1, 2,
5.
3, 4, 5.
Yeah, man, a 5. 5.
All right, and then 3, 0, 1, 2,
I can't see it better than my girl. You talk to you tell Shay
3, and then don't care. How much don't care after the 3, 0?
1, 2, 3, 4, 5, 6 this time.
Yes,
Right?
6.
1, 2, 3, 4, 5, 6. And then what happened after that?
And a 0.
A 0.
Yeah, then you have to go scroll up now so I can't see your side.
Oh,
Or scroll down. Check out. So after the single 0.
here, don't care.
Another,
All
yeah, so 0.
Mm-hmm.
And pure don't, well, 1, 2, 3, 4, 5, 6, 7, 8 don't care.
1, 2, 3. I'm counting my don't care. Then we have 1, 2, 3, 4, 5, 6, 7, 8. And then
And a 1.
1. And then
then
here don't care.
3, 4, 5 don't care.
2, 3.
Oh, there's someone have full of pin tongues so long.
And then what? It finish?
Yes, sir.
That means I do something wrong.
It's a good thing.
1, 2, 3, 4, 5, 6, 7, 8 don't care. A 1. And then 1, 2, 3, 4, 5. 5 don't care after that.
Yes, sir.
All right, we can start from the top. 2, 0.
But now I see the whole table.
Sir, you have to scroll up so we can see the Excel sheet.
Oh,
Nobody else in there have Excel sheet.
a 3, 0. No 3, 0. This 1, 2, 3.
Yeah, then that 3 0 with this one. Are
A
you
2,
right?
you tell me. I
I
then
three
tell
with
me, say, two you tell me. And the zero, the third one, the right at the top. How we do this now? All right, so we have to correct that. That is 0. And
everything you have shift down.
what we can shift it down in the thing there. This is a don't care. This one is 0. So don't care must come right here, so a 0 must come right here, so
Sure.
so the 1 must shift down. Don't care must go here, so. So wait a little bit. The last digit is what? Let's shift the table again. So don't care. All right. All right. So this is a table that we have with the logic converter. If you have multi-sim, it may work out much better. So you just simplify. I see it come out to in this case here. You see in AB, which is really
Yo,
so
you're not gonna know me.
so JA. That is what JA would do.
Let me add my gum or get some food down.
Yes. You have to give it.
Sorry, that's what I'm saying. Sorry if I speak to you, muted.
Sorry. All right, so JA is I1 multiplied by I2. I1 ANDed with I2. All right, when we do the simplification. Like I said, when you have so much don't cares, it usually comes down to something simple in the circuit. But what I'm saying now is that so we'd simplify the circuit, and then what we are going to end up with now is that we are going to end up with 3 flip-flops. This is A, B, C. The A stable in the circuit is just to provide clocking. It's not a timing device. And then so and then we're going to have our I1 and our I2 line that we're going to. So we're going to have to go through and simplify all of the circuit. Now the output is each flip-flop represents one of the states of the system. So if all off, then everything is off in the system. So this This one would be this first one is the inlet. Inlet. Second one is the stirrer. Try to do a better job of stirrer. And the third one is the outlet. Right? So that's why I say when you make the flip-flop, the output of the flip-flop be the state of the system. So if you connect A to the inlet and B to the stirrer and C to the outlet, then as it goes through, it's going to go from one to the next, depending on the conditions of the inputs A, B, and C. So you need, for the circuit, you're going to need 3 flip-flops. Now, in your sojourn on Earth, have you heard of the word monostable?
No, sir.
Have you heard of the word 555 timer?
You have our number?
Again, sir?
Yes, sir.
555 timer. All right, so we're going to have to use the 555 timer as a monostable because we're going to connect the input of B to a 10-second lapse. So when B turn on, it's going to turn on the 555 for 10 seconds and then it go back to its original state. All right, so we stop in there. So next week when we come, we're going to be discussing the logistics of drawing up the circuit, because there are some things that we have to, the I1 and I2 that I'm drawing here, that I'm talking about here. I1 and I2, they have to come from a multiplexer because I have to put the 4 inputs that I have to a multiplexer that I'm going to design to get I1 and I2 out. And I'm going to go through the same process. So I'm going to describe either that you describe a 4x2 multiplexer, or one of them is available in the multi-sim circuit. So you can just take it out. What we're going to talk about if you're going to design it, or because what happens is that your multi-sim is going to pick one of these. When one of these inputs goes high, then the output is going to reflect that one of these inputs is high. So those are the things that we're going to talk about next week: the monostable and the multiplexer that we're going to need to sort out. And then we're going to discuss further. Suppose we wanted to use less flip-flops for the states that are here, then we could. We could reduce, because we have 4 states, so we could just use 2 flip-flops and do the same circuit. So we're going to discuss that next week as well. And then next week we're giving you assignment. Next week Friday we're giving you your first 30% assignment for you to work on. All right.
That would be like a small project, like.
Yeah, we can. I'm going to just talk about the conveyor belt project. We're going to do a circuit that will run a conveyor belt, either a conveyor belt or a garage door, whichever one. Both of them in the book. There's either the conveyor belt or the garage door. All right, and then we will discuss how we discuss the circuit for that. So next week you get your first assignment, and then we're going to talk about PLC after that. Okay. All right. So we're going to stop here for today. I'm going to continue simplifying it, and then so next class I will come with the simplification of the different values that we have in this circuit. All right. So we're going to do that next class. But I was just going through the tedious process to say that You go from inputs to states. And when you go from input to states, then what are you going to do when you have your particular state? So next week, we're going to talk about reducing this because engineering people supposed to be cheap. So somebody going to say, "Well, so why are you using 3 flip-flop when you can use 2? So we're going to discuss how you use 2 flip-flops and how you get a smaller circuit, but I need you to understand the process first of all. And then we go to 2 flip-flops on a smaller circuit. All right? So that's what we're going to do next week. So everybody all right with that?
Yes, sir. Good.
All right. So because like I said, this circuit can be done with 2 flip-flops, but you have to understand. So it requires $1 more to make this circuit as to the one we're going to talk about next week. But $1 less if you're producing 50,000 of them. You see that is a whole heap of savings. So just bear in mind. So that's what we're going to do next week. Talk about how you can reduce the number of states or number of flip-flops that you need. All right, because the thing says 1 flip-flop per state, but you don't have to use 1 flip-flop per state. You can use less. All right, so next week.
All right, sir.